Hello friends, hope you are having a fantastic day today. So in this video, we are going to solve an awesome LeetCode problem that has been asked in tons of different companies. So without any delay, let's get started. So the LeetCode problem we are going to solve today is called sort list, and you can see that this is a LeetCode medium problem and also a very well-liked problem on LeetCode. This has been asked at tons of companies, and that's why you really need to pay attention. Now the problem statement is really simple to understand, that we are given the head of a linked list and we need to return the entire list in sorting ascending order. So if we see an example over here, we are only given the head of the list, that is this value number 4, and then rest of these values we need to iterate over using the linked list, and in the answer we need to return a sorted linked list that looks like this. And you need to do this problem. Now this is not specified over here, but in the follow-up definitely the interviewer is going to ask you that they are going to ask you to solve this problem in big of n log n time complexity and also big of 1 space complexity. So this becomes a little bit tricky in order to how to achieve both of these values in terms of time and space complexity. So we will try to target these things and think that what is going to be our thinking like in order to solve this problem in this much time complexity, and also without using any extra space. Now logically, let's assume that instead of this being a linked list, let's assume that we are given a simple array. And this is an unsorted array that we need to sort, and we need to sort this in n log n time. How would we solve that? Suppose we are given the values like 2, 4, 7, 1 and 3, something like this. Okay, so this if we have to sort this unsorted array, there are actually bunch of different methods that solve this problem in n log n time. We can apply like quick sort, or we can apply merge sort. Both of them are going to be really popular. We can also use like heap sort. But good thing about array is that in order to access any single variable, we can do this immediately by knowing that what is the index value, and then we can simply access this value. We don't have the same luxury to do so in our linked list. So that adds a bit of complexity, and that's why many companies love asking this question. Okay, now let's try to do the merge sort for this given array. So the logical thing is we are going to first find the middle pointer and break the array into two pieces. So first piece is going to be values 2, 6 and 4, and second piece is going to be value 1 and 3. Now we will check that are they sorted. Now in this case, this array is already sorted, so we don't need to do anything further. This is a good candidate for us. But now for this portion, this is not sorted, so we are going to again repeat the same process. So once again, if we break this down into two pieces, we will have one piece with value 2 and second piece with value 6 and 4. Once again, so currently we only have one value, so this is already sorted. We can't do anything much with this. This 6, 4, is it sorted? No, it's not sorted. So if it's not sorted, what we will try to do is we will try to sort this. But since there are only two elements, if we break them apart, it's going to be one element each, that is going to be 6 and 4, and then we can simply swap these values and it would be very simple to sort this one. So after completing this operation, what we will be left with is we will be left with a value like 2, and then this is going to be 4 and 6. So now currently this portion is sorted, this portion is also sorted, and this portion is also sorted. So now we have three different arrays that we are trying to sort, and this is going to be very simple to do. So what we will do is first we will take these two arrays 2 and 4, 6. So first we will compare the very first element with the very first element, and that's the only thing we need to do. And this operation can be done in log n time because we already know that both of these are sorted. So whichever value is smaller is always going to append first. So in this case, since the value number 2 is smaller, so we will be left with a piece 2, 4 and 6 as one piece, and second piece is already 1 and 3. So once again, now we are going to compare these two values, and we can see that this value number 1 has to go first. So we are going to put this value number 1 over here. Then once again, we are going to compare this value number 2 with value number 3. So since 2 is smaller, so once again, we are going to put 2 over here. Next, we are going to compare this value number 4 with value number 3. So since value number 3 is smaller, so we are going to put it before. And then for whatever the rest of the values are remaining, since this array is already completed, done, we can simply append all the values that are remaining as it is. So we are going to add values 4 and 6 as it is. This is how merge sort typically works in an array, and for that we actually have to use extra space because we need to store the array and do all of these manipulations. Now the target is we will try to replicate the same thing. The good thing about linked list is that we don't have to worry about this extra on space because we are working with linked list. So we can actually use pointer pointers to just point to the any particular value that we are trying to do, and we can just manipulate the nodes in the easiest manner. Now let's try to see that what the solution is going to look like. So number one thing is that in the linked list, we are only aware about the very first element. We don't know that what rest of the elements looks like, and we have no way for verifying. So let's assume that the values currently given are like 4, 3, 1, 2, and 5, something like this, 6. Okay. Now what we need to do is, in order to apply the merge sort, first we will need to find the mid pointer, and we don't know how many elements are currently in the linked list. We only know the head element. So we know that if we have to find the mid pointer, all we need to do is use fast and slow pointer method, and by doing this we would be able to find the mid pointer quite easily. For those who don't know how fast and slow pointer works, is that we are going to have two pointers, fast and slow pointer, start at the very beginning of the linked list. Fast pointer is going to jump 2 hops, and slow pointer is only going to jump 1 hop every single iteration. So the moment we encounter that either fast pointer is at the null location or fast.next is the null location, then we have reached to the last node for the fast pointer. And the moment fast pointer reaches to the last node, whatever the position of this slow node is going to be the mid pointer. So this is how we would be able to identify the mid pointer. Now let's try to apply the same logic. So for this one, we are going to have two halves. First half is going to be 5, 3, 1, and second half is going to be 2 and 6. Now 2 and 6 is already sorted, so we don't have to do much. But for this half, once again, we are going to find the mid pointer. So one half is going to be 5 and second half is going to be 3 and 1. And once again, this half is not sorted. So once again, we will sort this one 1, 3, and then we will have 5, 1, 3 as one half. Once again, these two are not sorted, and again this is not array, these are linked list pointers. So once again, recursively we are going to repeat the same process, and we will have 1, 3, 5 as the sorted arrays, and then we will have another sorted linked list, and another pair as 2 and 6 as the sorted linked list. We will merge these two together, and we will find the values 1, 2, 3, 5 and 6 as the final sorted linked list, and we can do this in place using the pointers. So when we see that in the code, we should be able to find or understand how it works. So this is the whole approach. What we are going to do is, for the linked list, we are going to use the merge sort approach, and in order to find the mid pointer, we are going to use the fast and slow pointer method. So you see, in this problem, we are applying multiple concepts that are really important for many different things, and that's why this problem has been really popular in many different companies. Time and space complexity, we already know. Time complexity is going to be big O of n log n, and in terms of space complexity, it's going to be big O of 1, because we are not using any additional space. We are actually going to manipulate the pointers, and the whole thing, because it's a same operation being done repeatedly, it's a recursive approach, and we can just solve this problem using recursion. So now let's see the code for this. So if we see the solution, first what we are going to do is, we are going to have our sort list method that we are going to recursively call for the different linked list head. So first we are going to have our terminating or base case, that if the current given head is equal to null, we return head. If head.next is equal to null, then also we return head. Next, we will have to find the mid pointer. In order to do that, we are actually going to use an extra helper method called getMid. So first, let's see the getMid method, where this is very simple. We are just simply using two pointers, fast and slow pointer, in order to find the mid pointer. And the moment we get the mid value, we simply return the mid value. So we have the mid value over here. Then we also have the left node, that is going to be the start node, or the very first node that we are given in the input for the sort list method, and the rightmost node, that is going to be the mid pointer node, or the second half. And then we simply need to apply our merge sort method. So we are going to call another helper method called merge. And in this method, we are going to have, first of all, couple of nodes, dummy and tail node, in order to keep track of different pointers. Then we are going to simply check that while list 1 and list 2 are not null, we are going to compare the values. If we find out that the values are not correct, we are simply going to swap the values, and then we are going to keep on iterating till we reach to the next element, or the very last element. And that's it. So this is how we are going to do our merge sort operation. And this is the whole code. Let's try to run the code. Okay, seems like our solution is working as expected. Let's submit this code. And our code runs very fast compared to a lot of other solutions, and it is also very efficient in terms of memory usage. So once again, I will be posting this code solution into our GitHub repository, and link to that GitHub repository is in the description.